Alright, one more completing the square problem. We're given 4x squared minus 8x minus 3 is equal to 0. So we'll move that 3 over. So we have 4x squared minus 8x is equal to 3. And on the left-hand side, we could factor out a 4. And then we have 4x x squared minus 2x left inside. So if we were to focus inside the parentheses, we know that we have a negative 2 as our b term. So we want to divide that by 2 and then square it. And if we do that, that's really negative 1 squared. And that's really equal to 1. And so we're going to add 1 inside the parentheses, and then we also have to do it to the right-hand side with whatever we added on the left-hand side. So we're going to add a 1 right here. And keep in mind, when we distribute this 4, we're going to get 4x squared minus 8x plus 4. So technically we added a 4 to the left-hand side. So we'll add 4 to the right-hand side as well. Alright, so now this is going to be 4 times, and this thing is factorable now. It's really x minus 1 squared is equal to 7. Now remember, when we look at this thing right here, the way that we can factor it is we need two numbers that multiply to give us 1, but add to give us negative 2. Or we could just think of it as we take half of b, and that's what this number right here is going to be. So this is x minus 1 squared is equal to 7 over 4. So x minus 1 is equal to plus or minus the square root of 7 over 4. So that denominator we can simplify. It's really 2. And then we can add 1. So there are the two solutions. 1 minus the square root of 2 over 7, square root of 7 over 2, and 1 plus square root of 7 over 2. Alright, so now we want to look at equations with radicals. These are other types of equations. So whenever we see a radical, meaning the square root symbol or any root symbol, and it has some expression under it, we want to try to get it by itself. And then we're going to have to square both sides to get rid of it. And if it has more than 1, we're going to have to choose 1, get it by itself, and then later on do the same to the other one. But for now, we just have 1. So we can say this is really the square root of 5 minus x is equal to x minus 3. And now if we square both sides, on the left we have 5 minus x. On the right, if we FOIL that, we're going to have x squared minus 6x plus 9. And so now we need to get everything on one side. So we'll add x and subtract 5. So x squared minus 5x. And 9 minus 5 is going to give us 4. And that's going to be equal to 0. So it doesn't matter if you write this on the left or the right. Just make sure you keep the signs exactly the same if you switch them. And now we know that we can factor this. Two numbers that multiply to 4 but add to negative 5, that would be x minus 4, x minus 1. And so we end up with x minus 4 equals 0, x minus 1 equals 0. So 4 and 1. Alright, so let's look at one with two radicals. The square root of x minus 1 plus 3 is equal to the square root of x plus 20. So remember, right away we need to make sure that one radical is by itself. That way we can square both sides and get rid of it. It already is. And so on the right, we'd have x plus 20. On the left, we have to FOIL this thing. So we're going to take this square root of x minus 1 plus 3, and we're going to multiply it by itself. And the only way that we can do that is by FOILing. So when we multiply the firsts, we get x minus 1. The outer would give us plus 3 square root of x minus 1. The inner, same thing. And then last would give us 3 and 3, that's 9. So when we simplify this, it's going to give us x plus 8 plus 3 plus 6 square root of x minus 1. And now we want to simplify if we can. So the x's we can subtract from both sides, those will cancel. We need to subtract 8 from both sides. So now we have 6 square root of x minus 1 is equal to 12. And this radical, again, needs to be alone, so we have to divide both sides by 6. So now we have the square root of x minus 1 is equal to 2. Now we can square both sides again. On the left, we have x minus 1. On the right, we have 4. And so now x is equal to 5. So in this case, we only got one solution. And we want to check it. So if we do that, the square root of 5 minus 1 plus 3, we're hoping that that's going to be equal to the square root of 5 plus 20. So that's the square root of 4, that's 2, plus 3. Is that equal to the square root of 25? It is. Now if we go back to the previous problem, if we check these, notice we got two solutions in this case, because that x didn't cancel out. We want to make sure these are correct. So we have the square root, if we check 4, of 5 minus 4, plus 1. We want to know if that's equal to 4 minus 2. And so we'd get the square root of 1 plus 1. Is that equal to 2? It is. Now we'll check 1. So the square root of 5 minus 1 plus 1, is that equal to 1 minus 2? We can already see there's going to be an issue here. So on the left, square root of 4, that's really 2 plus 1. Is that equal to 1 minus 2? 3 is not equal to negative 1. And so if we go back to this problem here, 1 actually doesn't check out.